For the reader in unit number 8, um, I feel like a lot of these questions are more direct than usual, so they don't require big explanations, but there might be a few details to highlight. So this should go pretty fast. Number 47, about acid rain, I just need to remind you of something because kids get the wording wrong. Um, Something that acid rain does is it dissolves metal from rock or from soil. And the one big distinction that we need to use our words carefully here, acid rain doesn't make metals. Acid rain releases whatever is found in the area. Some metals are toxic. So in the Central Valley of California, a lot of our bedrock has selenium. So more acid rain means that there's more selenium in runoff. That can be dangerous. The acid rain doesn't make the selenium, it just helps that metal release from soil or bedrock. If you have aluminum in your rocks, then acid rain will put more aluminum into the water. A lot of areas have lead in their bedrock, and so acid rain puts more lead into the water. It doesn't make anything, it just helps release whatever is otherwise tied up in rock. And remember that all metals come from rock, that's what mining is. So any place that has a lot of metals nearby, like mountainous areas, if you're like in a mining part of the world, then you'll have more metals in your water. Just that one key word doesn't make metals come out of soil or bedrock, it releases them from soil or bedrock. I got to apologize. Number 49 and 50 are probably outdated. There was this big political debate that went on like a decade ago. And so I had these in my old reader and I didn't want to change all the numbers. So I'm using a lot of stuff from the past, and I'm sorry, these are just outdated. You can ignore them. Number 51, again, how the paleological record helps us understand climate change now. You can look at old extinctions, and that helps us understand how climate will affect biomass in the future. Number 52 is optional for people who are chemistry nerds, but this is a really cool option. Very interesting. You can get about 20 pounds of carbon dioxide gas from burning about 7 pounds of gasoline. And it's really not rocket surgery, I guess. You're taking oxygen from the atmosphere and you're adding it to the carbons, and oxygen has weight and so does carbon. So the liquid stuff, when it becomes gas stuff, we think of that as being lighter, right? Because gas is like not sticking to the earth. The secret is that when you make gasoline liquid into the exhaust fumes in the air, those have a whole bunch of oxygen attached to the carbons, and so you've made more molecules included, more atoms included in those molecules. And so CO2 weighs a lot more than the gasoline it was made from. This is why our cars make tons and tons of CO2. And I always thought that was like an exaggeration, because like I did the math, I'm like, I'm not really burning tons of gasoline. How could I make many tons of CO2? But this math I thought was neat. So for anybody who's into it, this is optional, but it's an interesting article. It's pretty straightforward. You should give it a shot. Number 53 is not necessarily straightforward. So this is an interesting detail and we got to get it right. This is some nerdy stuff, and this was a starred study goal. Okay. We know that a source of CO2 in the atmosphere is deforestation, not news. Cut down a bunch of trees, release all the carbon from the lignin bonds and other carbon bonds in the tree. So burning biomass puts CO2 into the air. Deforestation adds to global warming because it adds CO2. It's a main source of CO2. Nothing new there. Apparently, though, small prescribed burns, what we do to put patchiness back into the landscape, small controlled burns, actually lower global CO2. Here's what happens. When we prevent wildfires, the forest kind of stops growing because it's all just like socked in with dead material. The trees have like run out of nutrients for growth because there's a whole section of the understory that's all dead matted kindling. It's just stuff, and there's a lot of nutrients locked up in that. So when we do thinning, which is artificial patchiness, we remove undergrowth and make the forest less dense. All that stuff burns, that gives off some CO2, but all those ashes go back, and in a controlled burn, you leave the big trees. And then now with all those ashes, they can grow back, and that uses up more CO2 than you release by burning the undergrowth. This is interesting. If you let Santa Barbara burn in those huge landscape destruction fires, everything will burn. So huge out of control wildfires, like we have in California recently, make a lot of CO2. But instead, if you could go in there and do little prescribed burns, take out a whole bunch of undergrowth, make a pile, burn that. That's going to make a little CO2, but then the trees will grow so much more that they soak up all that CO2 and then some. My explanation kind of sucks. I think that the article says it more clearly, but I thought that was really fascinating. I found the shortest article I could on this topic. Number 54, we've talked about a lot. So there was this mystery where people couldn't figure out how the heck some parts of Europe were warming up differently than other parts and why. And again, it has to do with how high water vapor goes. High clouds are generally a cooling influence, while low clouds cause a lot of warming. There was a debate, like why some parts of Europe are heating up more than others. How will new water vapor affect global climate? And I don't know, I thought 54 was a cool throwback to that time when it was a mystery. If you ignored the article, just make sure you know what I just said. It's written on the screen. Number 56 is really compelling. So during COVID times, most of America heard about the World Health Organization as this like touchy topic. Are they good? Are they bad? Do they know? Don't they know? Are they helping? Aren't they helping? But that's not entirely fair. The World Health Organization is the largest international body of medical experts on the planet by a lot. Like it sounds, World Health. And there's like bazillions of people from a bazillion countries. Without getting into the World Health Organization's track record on COVID, which is actually not bad at all. It was just a new disease that kind of confused a lot of people, but the World Health Organization didn't really get much wrong. It just snuck up on a lot of people. Without getting into the COVID thing, the World Health Organization has for a long time been warning that climate change is a health threat. And this article has a really good detailed list of problems and reasons for why the World Health Organization and much of the international community believes that climate change is one of the biggest threats to global health, that a whole bunch of people will face new diseases, struggle to get food and water, and so on. We've talked about this elsewhere in the unit, but I thought this article was helpful. And number 59, I think that this is like such an amazing topic. Okay. We changed the way that our planet handles climate, kind of by accident. Like people saw it coming, but we messed up and changed the way that our planet handles climate. So we increased the amount of greenhouse gases, making our planet hotter. Now there's all these snowball effect, positive feedbacks going, and we're just really comfortable with our modern technology, so we're probably going to keep changing the climate. And so there's one alternative, which is, change our society globally. And I think we should, but I think we all understand that's a pretty tricky topic. What if we just changed the Earth again to change the climate on purpose in the opposite direction? That's called geoengineering, where you intentionally manipulate the variables to manage climate change. If we could change climate upward by accident, couldn't we change climate downward on purpose? And like, if you take 10 big cities and you paint all the roofs and the roads white, you can reverse 1 year of global warming. There's a lot of big cities, so you could probably reverse a decade or two of global warming in less than a decade. What if you shot trash into space and made an asteroid field of artificial material that would block sunlight and the planet gets cooler? Or you could intentionally dim the Earth by making clouds, but particulates high up in the atmosphere. Or what if you fertilize the ocean and make a whole bunch of new biomass? Apparently the biggest limiting factor to algae growth is iron. So we could go into all the landfills and dig up all the old iron stuff and put it in giant grinders and then dust the ocean with iron, and we would make more algae, which makes more plankton and makes more little fish and makes more big fish. But more algae also soaks up all the CO2, turns it into biomass. I don't know, man. I can see why some parts of the world would get a little nervous, right? Hold up, America, you already wrecked things. Stop playing with it now. But I actually kind of think that it's worth a thought. I mean, if you're messing with a big ship and it starts to sink because you're an idiot, you probably should think about how to keep it from sinking. Maybe you take some chances and try another idiotic idea. I might just be an idiot. But I don't know. I think it's interesting to engineer the climate, and this conversation is picking up a lot of steam. Since we don't seem to have a very real plan for addressing climate change, maybe we just need to start steering the climate change. I don't know. There's a lot of details, but it is an interesting topic in my humble opinion. So I put that article in there just as a fascinating concept that probably doesn't end up in a lot of classes. Okay.